Hi everyone, today I will talk to you about how to make a temperature and a gas detector with Arduino. To be able to do this, first of all we need the TMP36, the analog temperature sensor. It provides a linear analog output directly proportional to the temperature expressed in degrees centigrade, and that is why we interface it with Arduino through one of the analog ports. It has three pins: VCC, analog voltage output, and the ground when viewed from the flat side. To be able to use it with Arduino, we must first convert the output voltage into degrees centigrade through the formula we already seen in the previous lesson. In order to read the values of temperature and the concentration of the gas, we use the liquid crystal display, in acronym LCD. It is a type of display that uses the light modulation properties of liquid crystal. To use it with Arduino, you need the Arduino liquid crystal library that allows you to interface the display. It has 16 pins, already explained above. To warn us if the sensors detect a certain value, we use a buzzer, an audio signaling device, which can be mechanical, electromechanical, or piezoelectric. The buzzer we use is active, that is, if powered with a suitable voltage, it produces a tone at a preset frequency. It has two pins: VCC, which is usually recognizable from a plus above it, and ground. Together with the sound of the buzzer, we also use a visual signal through a red LED diode that will turn on together the activation of the buzzer. To detect the gases, we use the MQ2 gas sensor to detect the concentration of gases in the air, such as LPG, propane, methane, hydrogen, alcohol, smoke, and carbon monoxide. The MQ2 sensor is also known as chem resistor. It contains a sensitive material whose resistance changes when it comes in contact with a gas. This change in resistance value is used for gas detection. This sensor works with a voltage of 5 volts, and it is capable of detecting gases in the concentration between 200 and 10,000 parts per million. This sensor contains a sensing element, mainly aluminium oxide ceramic, coated with tin oxide, encased in a stainless steel mesh. Oxygen is absorbed on the surface of the sensing material when heated in high temperature air. Then the donor electrons present in the tin oxide are attracted to this oxygen, and is preventing the flow of current. When reducing gases are present, these oxygen atoms react with the reducing gases, and that decreasing the surface density of the absorbed oxygen. Now the current can flow through the sensor, which has generated analog voltage values. The voltage values is higher when the gas concentration is high. It is made up of 6 pins distributing on 2 rows formed by 3. The external pins are named A in one row and B in the other, and they are interchangeable. Usually the pins A are connected to power supply, while one of the B is connected to load resistor and the other is connected to the analog input of Arduino. The central pins are named H, and the one in A row is connected to power supply, while the one in the B pin row must be connected to the ground. If the gas sensor detects a certain concentration, it will activate the relay, an electrical switch which, thanks to an electrical impulse, closes and opens circuits. This device works thanks to the current variations that affect the mechanism of another circuit. The relay therefore does not interrupt the flow of current, but diverts it. The relay consists of three parts: the coil, the anchor, and the electrical contact. Inside the relays, the role of switches is played by the contacts, which are fixed and mobile. When the relay is at rest, the moving contact is in contact with one of the two fixed contacts. When the relay is energized, that is when the coil crossed by the electric current, the situation is reversed and the moving contacts moves to the other fixed contacts. The relay we used was powered by a 9-volt battery and it has 8 pins, which includes 2 switches. Pins 4 and 13 are the moving contacts of the respective switches. Pin 6, 8, 9 and 11 are the fixed contacts of the respective switches. Pin 1 is ground pin and pin 16 is the power pin. When the relay is activated, it closes the solenoid valve, which in our case is simulated by a light bulb, which when it's closed means that it closes, while opposite if it's off. A solenoid valve is used to close or open a passage of fluid in a circuit by means of an electric command. In our case, closes the gas. A solenoid valve is a combination of two basic functional parts: a solenoid, that is the electromagnet, and a ball body with one or more passages. According to the operating principle, the solenoid valves are divided in two categories. Direct acting solenoid valve means that the passage is closed or opened by a seal mounted directly on the magnetic core, which is activated by the coil. The operating pressure is therefore directly linked to the passage diameter and the power of the coil, and the minimum operating pressure is equal to 0. The solenoid valve with the servo-controlled action has a pilot orifice and a main orifice. The magnet will open and close only the pilot, so the maximum and the minimum operating pressure will not depend on the power of the electromagnet, but on the construction characteristics of the seal on the main orifice. A fundamental characteristic for this type of solenoid valve is the minimum operating pressure, which is always greater and different than 0. All solenoid valves are divided in normally closed and normally open. Now let's see how we made the sketch through the Arduino program.
And there we are in the Arduino screen. Now I will explain the sketch I wrote. At the beginning I include the library necessary to use the display, liquid crystal. Then I establish the variable for the gas sensor values and declare all the pins that I will use on the Arduino. In pin 10 I will insert the red LED, in 9 the relay, while in pins 7, 6, 5, 4 and 2 the display, which will then be initialized with the liquid crystal command. Then here, through the command LCD begin, started the display by setting the number of columns and rows of the display. In order to view the Arduino serial monitor, I use the serial begin command. Then I declare the pin A0 and A1 as input, while the pins of the LED and the relay as output. In the loop I initially cleaned up the display through the command LCD clear, and then I did the calculation to be able to convert the temperature from analog to digital. Then I read the values of gas sensor and started the communication with the serial monitor. Here instead I set myself how to make the display read the values. In the first line it writes the degrees, and in the second the concentration. With cycle of if, I got to establish that if the temperature is greater than or equal to 34, or the concentration is greater than or equal to 550, I turn on the LED, while if the temperature is less than 34 or the concentration is less than 550, I turn off the LED. I continue with another cycle in which if the concentration is greater than or equal to 550, I close the relay, while if the concentration is less than 550, it opens the relay. Finally, I set a delay to be able to read the values in the display. Let's move on to the simulator, in which, to simplify both the coding and the circuit, we connect the buzzer in series to the red LED, since it must sound at the same time as the LED, and we also use two breadboards for greater order. Having said that, we start the simulation. And we can see that the display read the values returned by the sensors, and if we increase the temperature above 34, we see the LED lights up and the buzzer sound, while if we approach the cloud of smoke to the gas sensor, we notice that the concentration rises, and consequently the LED and the buzzer are activated, but the relay is also closed, which causes the light bulb to turn on, which should simulate our solenoid valve. Thanks for watching and see you next time.